What you're looking at here is the Raspberry Pi 02W. This is effectively a full fat SPC single board computer that can run a complete Linux desktop. It's just running on top of ARM. It is a quad core 1 gigahertz processor. It has 512 megabytes of RAM. It is more than powerful to do a lot of the stuff that you would normally want to do for any kind of like embedded projects. There's also the ability to run bare metal stuff, which means that you don't run an operating system. Um, Things that I saw on that, I think was like Circle was one example. I tried to find a bare metal version of Rust that would run here, but it wouldn't. And technically, if you wanted to run like a PHP, Python, Ruby on Rails type of thing with a database, you still get plenty of all that stuff available to you. When you boot up VMs, actually, this is kind of like very close to like VM performance and that. So completely overkill for what I wanted to do, which is be able to use something that was completely low power usage, but also something that doesn't need to be exactly that powerful because this is beyond powerful. I'm going to show you why, to be honest. And then right next to this is the Raspberry Pi Pico W. So it is a wireless version for the Pico. This is completely different than the Raspberry Pi Zero 2W in that this is a microprocessor, whereas this is a full fat ARM processor that you can run a traditional desktop Linux on top of. There's a lot of difference between these two, but let me just go ahead and show you the benchmark I did for this, kind of the example. These are not being the exact same benchmarks. I can kind of show you what that would look like. So let me just go ahead and jump into this. So first off, the benchmark I have here is based off Rust. I am using Rocket with Sled. So Rocket is a high-performance web application, is a multi-core one, and it gives Sled is a key value database like Redis would be, but they're all both Rust-based. And so here's like an endpoint I have for signing up. Insert it to the database, auto increment the ID because Sled doesn't have a way to actually do that out of the box. And so if I go to that example here, you can see that, it's just auto increment. These are all atomic inserts and writes and everything else is writing to its actual disk. So there's nothing to worry about like losing the data and stuff like that. So pretty cool in that regard. And you get the full featured. This uses about like 30 to 40 megabytes. And when I put it to full tilt, it goes about 60 megabytes. But here you can go ahead and see that if I go ahead and run this, which is basically, this is JMeter. JMeter is a benchmark tool, just like Apache Benchmark or Hey or Work. But you can set up some couple things like make sure the response has this in it. And you can see each of the responses in an aggregate response. So if I go ahead and hit play, you can see that the throughput is very slow. Why is that? Did I change the threads? Okay, let's clear this one more time here. Oh, because I have both of these enabled, so let me disable this real quick. I didn't mean to disable this here. Okay, so let's try this one more time, aggregate results, and I get around like 2,500 plus requests a second. Like I said, way too much in terms of what I needed to do, especially when I'm just going to jump down to some lower level code to have this done. And remember that this is going over a Wi-Fi module and specifically a 2.4 gigahertz Wi-Fi module. It doesn't support 5.0 gigahertz. So it's slower, but you're still getting an insane amount. So there's so much room to grow here in terms of like building out a low level code base. And even if you could get to bare metal, that'll be even faster if it was possible, at least in Rust. Okay, so move this out of the picture here. The next one I was testing on was the Pico, and you can still use Rust, but there's a lot more limitations here. First off, you're working with a microprocessor, so you can't run a full Linux distribution. You can't do dynamic memory allocation, at least what I see in Rust that you can't do. And you have far less RAM. I think it's like 16 megabytes of RAM. I could be wrong. Um, but it's super low. And the code is very different. So I can't use Rocket. I can't use um, Sled because those all require the standard library. You can't use the standard library in Rust when writing to this. And so here is just some code here. Now, unfortunately, what I'm using is called, not unfortunately, but what I am using is called Embassy. So if you look at my cargo, You see that I have a bunch of embassy stuff attached to here. The Wi-Fi module is this thing here, and they give me the example of TCP connection. Um, I need to work on that a little bit, and I'll explain a little bit why. But they don't have an HTTP server you can use, so there's nothing like Rocket available that I found at least. So I was just starting to use the TCP server and write a simple HTTP stack on top of it. And that's what you see in the browser here. So every time I refresh, I just get hello client, but it is providing all the HTTP headers that you would normally see if you were doing like raw HTTP development stuff. Uh, with that said, I can go ahead now and disable this and enable. Now, one gotcha here is every time I refresh my browser, and you can see this here, the light will turn on and off. That means, at least in my code, that the HTTP server that I have here is completely turning off and then turning back on based off the loop. I can potentially fix that. I was trying to fix it, but I was kind of getting frustrated because I'm just trying to deal with all the memory allocation issues. Not specifically a Rust problem, but just because you don't have that dynamic memory allocation available to you, it's kind of a pain in the butt. But you can see here, I set it off and then I listen to 8,000 again. And this is going to play an important role for benchmarking. So if I go ahead now and I play this here, you can see that my throughput's around 50 requests a second. Um, but my error rate's 50%. And that's because what I just said, every time I get a response, I turn off the HTTP server and restart it. And you can see the headers that come through as well as the hello client. And then the next request, and this happens, you can see every single time, every other request comes through and I'm not getting it. But I'm getting, depending on the run that I do, will be about 50 requests a second, which is cool. Um, Still more than enough than what I need, and honestly, I think I don't mind it turning off then, because requests don't go that fast as it would for a benchmark. Technically, I can kind of work around that. But I do forgo still quite a lot because, like I said, I don't have any dynamic memory allocation. Everything has to be specified up front. When I'm generating this dynamic header, I have to be very careful about it, and everything needs to be kind of statically defined. So, for example, my headers, I have 5 here. Even though it says UBit 8, this is actually inferred, and it knows the exact length of all these and can work with that when compiled down to the binaries there. I do have a Docker file. It's not really working just yet, but I have documented like everything I would need to do for all the builds and using elf2u LFT from the Pico SDK to get it to the Pico and stuff like that. Um, but yeah, this is a cool little starting point. I just wanted to share it for anyone who was interested in that. Just if they really did want to write a little web application, they can do so. And this uses like a third of a watt at full power, which really sips on anything here. This can run technically on a battery, a small battery if it needed to. I believe someone said that their test that they were doing, they got like 10 hours running on. Can't remember. It was like 800 milliamps for 10 hours, which it's fairly small for this here. And yeah, so what I want to do next is attach an SD card to here because I do want to serve some files and be able to write to it for a database and reprogram my little chore tracking thing in pure Rust. I got to do some more work with the HTTP server stuff so it's not restarting every single time. I will see how that works out, but regardless, pretty cool. And like you get all the pins, I believe, that you get with the Raspberry Pi. They're just split between the two sides. Or sorry, Raspberry Pi 0 2W there. I am getting another board as well. That will be the Orange Pi 03, which is a different form factor, but it gives me more RAM to work with, and I may look towards that for hosting some other non-low level code stuff, but I'm definitely going to be working towards this to get a full working example on my part. This way I can load it up on my phone or something like that and interact with it that way.